The Coconut Oil Miracle, 5th edition by Bruce Fife. Chapter 2, Saturation and Size. We hear the terms saturated, monosaturated, and polyunsaturated all the time, but what do they mean? What is saturated with? How does the degree of saturation affect health? Let me answer those questions. All fatty acids consist primarily of a chain of carbon atoms with varying numbers of hydrogen atoms attached to them. Each carbon atom can hold a maximum of 2 hydrogen atoms. A fatty acid molecule that has 2 hydrogen atoms attached to each carbon is said to be saturated with hydrogen because it is holding all the hydrogen atoms it possibly can. This type of fatty acid is called a saturated fat. A fatty acid that is missing a pair of hydrogen atoms is called a monosaturated fat. If more than 2 hydrogen atoms are missing, the fatty acid is called a polyunsaturated fat. The more hydrogen atoms are missing, the more polyunsaturated the fat is considered to be. Wherever a pair of hydrogen atoms is missing, the adjoining carbon atoms must form a double bond, which produces a weak link in the carbon chain that can have a dramatic influence on health. The concept of saturation can be described using the analogy of a school bus full of kids. The bus could represent the carbon chain and the students the hydrogen atoms. Each seat on the bus can hold 2 students, just as each carbon can hold 2 hydrogen atoms. A bus filled to capacity so that there are no empty seats would be analogous to a saturated fat. No more students can fit on the bus. If 2 students get off the bus and leave 1 seat vacant, that would be analogous to a monosaturated fat. If 4 or more students get off the bus, leaving 2 or more empty seats, that would be like a polyunsaturated fat. A school bus that is only half filled would be like a fatty acid that is very polyunsaturated. The length of the fatty acid chain or size of the school bus is also important. Some fatty acids contain only 2 carbon atoms, while others have as many as 24 or more. The 2 carbon fatty acid would be like a bus that only has 2 seats, so that it can carry a maximum of 4 students, 2 in each seat. A fatty acid with 24 carbon atoms would be like a long bus with 24 seats, accommodating 48 students. Acetic acid, found in vinegar, has a chain only 2 carbon atoms long. A longer acid chain may have 4, 6, 8, or more carbon atoms. Naturally occurring fatty acids usually occur in even numbers. Butyric acid, one of the type of fatty acids commonly found in butter, consists of a 4-carbon chain. The predominant fatty acids found in meats and fish are 14 or more carbon atoms long. Stearic acid, common in beef fat, has an 18-carbon chain. 8. The 14 to 24 carbon fatty acids are known as long-chain fatty acids, LCFAs. Medium-chain fatty acids, MCFAs, range from 6 to 12 carbon atoms, and short-chain SCFAs consist of less than 6 atoms. The length of the carbon chain is a key factor to the way the dietary fat is digested and metabolized and how it affects the body. When 3 fatty acids of similar length are joined together by a glycerol molecule, the resulting molecule is referred to as a long-chain triglyceride, LCT, medium-chain triglyceride, MCT, or short-chain triglyceride, SCT. You will often see medium-chain triglyceride, or MCT, listed as an ingredient on food and supplement labels. Both the degree of saturation and length of the carbon chain of the fatty acids determine their chemical properties and their effect on our health. The more saturated the fat and the longer the chain, the harder the fat and the higher the fat's melting pot. Saturated fat, like that found in lard, is solid at room temperature. Polyunsaturated fat, like corn oil, is liquid at room temperature. Monosaturated fat is liquid at room temperature, but in the refrigerator it begins to solidify slightly and becomes a cloudy or semi-solid. Table 2.2 lists the most common fats found in foods. The fats found in animal tissue, as well as our own bodies, are mainly the triglycerides consisting of stearic, palmitic, and oleic acids. Oleic acid is a monosaturated fat. Stearic and palmitic acids are saturated fats. The saturated fats found in food consist of a mixture of the different types. Milk, for example, contains palmitic, myristic, stearic, varic, butyric, caprylic, and capric acids. Each of the fatty acids exerts different effects on the body that are governed by the length of the carbon chain and its degree of unsaturation, number of double bonds. Saturated fatty acids with up to 26 carbon atoms, C26, colon 26, and as a few as 2 carbon atoms, C colon 2, in the chain have been identified as constituent of fats. Of these, palmitic acid C16 is the most common, occurring in almost all fats. Myristic C14 and stearic C18 acids are other common saturated fatty acids. Short-chain fatty acids are relatively rare. The most common sources are vinegar and butter. Milk contains tiny amounts of short-chain fatty acids. These fats are concentrated in the making of butter and comprise about 12% of its total fat content. Medium-chain fatty acids are also relatively rare, but found in moderate concentrations in some tropical nuts and oils. Long-chain fatty acids are by far the most common fatty acids found in nature. They provide the most efficient or compact energy package and thus make the best storage fats in both plants and animals. Fat cells in our bodies and those of animals are almost entirely long-chained, as are all fats in plants. The vast majority of fats in our diet are composed of long-chain fatty acids. There are only a few good natural sources of short-chain fatty acids. The best source, by far, is coconut oil.